For this implementation, we will be using NumPy, TensorFlow, and scikit-learn libraries. So we will import them, as you can see here. The iris flower dataset can be loaded from the scikit-learn library, as you can see here. Here you can see how we show the dimensions of the dataset, and as you can see, the dataset has 150 samples with 4 features. Here we have defined the function to compute the z-score of the data as a normalization method. In z-score, we subtract the mean of each feature from each sample value of that feature divided by the standard deviation. The mean and the standard deviation functions are implemented using TensorFlow library. So here you can see the mean and the standard deviation functions of the TensorFlow library. Beginning a session, running a session, and closing a session. In this part, we have found the covariance matrix of the multiplication of data matrix and its transpose. The TensorFlow library has all we need. This is the matmul function for the matrix multiplication. This is the SVD function that will give us the eigenvalues and the eigenvectors. Here we are running the sessions to get the NumPy values of the tensors. And here we can see the NumPy function arcsort for sorting the values of the eigenvalues in a descending order. One thing that we should keep in mind is that the principal components must be orthogonal. So in order to keep the orthogonality of the bases, the eigenvalues should not be equal. Otherwise, those corresponding eigenvectors would not be orthogonal. Thus, in this part, we have a for loop in which we find the repetitions of eigenvalues by using the NumPy function where. We must find the indices of repetitions of eigenvalues and delete them from the eigenvalues, sorted indices, and the eigenvectors. These eliminations are done using the NumPy function delete, as you can see here. After this part, we are all set. It's enough to determine how many principal components we would like to have for the representation of the high-dimensional data. The variable p shows the number of the principal components, and we can change it. Here we have chosen p equal to 2, as you can see here, to reduce the features from 4 to 2. In order to find the p principal components, we choose the first p rows of the eigenvector matrix. We are already sure that these components are orthogonal. The new representation of the data X is found by multiplying data matrix X with principal component matrix P. So Y is equal to Px, as you can see here, by using the matmul function of the TensorFlow library. And after running all of these, you can see that we have the results of representing 150 samples with 2 features instead of 4 features.